Hello everyone, I am Gabriel Silva-Atencio, and it's truly an honor for me to stand here today and present our in-depth research titled A Blockchain-Based Framework for Verifiable Sustainable Finance and Carbon Accounting in Banking. This research is being presented for two very significant events: the International Conferences in Computational Science and Engineering for Society, and the first International Conference on Leadership in AI, also known as ICONS2026. Let's take a moment to really soak in the significance of these conferences. The International Conferences in Computational Science and Engineering for Society bring together some of the brightest minds in the field, all focused on how technology can drive positive change in society. And the first International Conference on Leadership in AI, ICONS2026, is at the cutting edge of artificial intelligence research. Our research fits right into the intersection of these two important areas, as it combines the power of blockchain technology with the need for sustainable finance. As we look at the global financial landscape today, it's undergoing a remarkable transformation. It's pivoting towards a greener economy at an unprecedented pace. This shift is not just a passing trend. It's a fundamental change driven by growing environmental concerns and the need for long-term economic stability. To put this transformation into perspective, let's take a closer look at the increasing number of countries setting ambitious carbon neutrality goals. For example, countries like Sweden have set a goal to be carbon neutral by 2045. But it's not just Sweden. Many other European countries such as Norway, Denmark, and Finland are also on the same path. These countries are investing heavily in renewable energy sources like wind, solar, and hydropower. They're building large-scale wind farms off their coasts, covering vast areas of land with solar panels and upgrading their hydroelectric plants. These goals are not just about reducing emissions. They are reshaping entire industries, and the banking sector is no exception. In this context, the banking sector finds itself at the center of a storm. It's facing an enormous amount of pressure. This pressure is not just about making a few promises. It's about demonstrating genuine sustainability in every aspect of its operations. Let's take a moment to understand the current situation. The banking sector has long been operating in a culture where self-reported promises were the norm. For example, many banks would simply state their environmental goals without clear and verifiable data to back them up. They might say they're reducing their carbon footprint, but there was no real-time, reliable way to confirm these claims. Think about a bank branch. It might claim to be using energy-efficient lighting, but without proper monitoring and reporting, there's no way to know if it's actually reducing energy consumption. Let's say this bank branch has a large lobby area. They put in LED lights, claiming it's energy efficient. But without a proper meter to track the energy usage, we can't be sure if the new lights are really making a difference. And this is not just about the lights. It could be about the heating and cooling systems in the building, the use of paper and other office supplies, or the carbon emissions from the bank's transportation fleet. This approach has its limitations. It doesn't provide the kind of transparency and reliability that the market and society demand. When we look at the global scale, this lack of transparency can have far-reaching consequences. It can mislead investors, who might think they are supporting sustainable projects when in fact, they are not. And it can also undermine the efforts of truly sustainable businesses, as they struggle to compete with banks that make false or unsubstantiated claims. To give you a more vivid example, consider a bank that claims to be financing a large-scale wind farm project. On the surface, it seems like a great step towards sustainability, but without proper verification, it could turn out that a significant portion of the funds are actually going towards coal-fired power plants or other high-carbon activities. Let's say this wind farm project is supposed to have a certain number of turbines, but if the bank doesn't properly monitor where the money is going, some of the funds could be diverted to build a new coal-fired power plant nearby. This kind of misallocation of funds not only affects the environment, but also the credibility of the entire banking industry. And it's not just about the environmental impact. It also has economic implications. If investors lose trust in the banking sector's ability to support sustainable projects, they may be less likely to invest in the future, which could slow down the transition to a greener economy. That's where our research comes in. Our research is all about exploring the potential of blockchain technology. Blockchain has some truly unique properties. It's like a digital ledger that is decentralized, transparent, and immutable. This means that once data is recorded on the blockchain, it can't be altered without a trace. To give you a better idea, imagine a chain of blocks, where each block contains a set of data. These blocks are linked together in a chronological order, and any attempt to change the data in one block would require changing all the subsequent blocks, which is practically impossible. Picture a long chain of digital boxes, each holding important information, and once a box is sealed, it can't be opened and modified without leaving a clear mark. Let's dig a bit deeper into how this immutability works. Each block in the blockchain has a unique hash, which is like a digital fingerprint. If you try to change the data in a block, the hash of that block changes. And since the next block in the chain contains the hash of the previous block, all the subsequent hashes would also need to be changed. This makes it extremely difficult, if not impossible, to tamper with the data. It can be a game changer in the world of sustainable finance. It allows us to move beyond the old way of doing things, the culture of self-reported promises. Instead, it paves the way for a future where we have verifiable digital evidence. Now, let's talk about the structure of my presentation. Over the next 20 minutes or so, I'm going to take you on a detailed journey. First, I'll outline the problem in great detail. I'll explain why the current situation in sustainable finance is not working and what the consequences are. To give you a better picture, I'll share some real-world examples of how the lack of transparency in the banking sector has led to issues. For instance, there have been cases where banks claim to be investing in green projects, but in reality, the funds were going to less sustainable ventures. These examples are not just isolated incidents. They are symptomatic of a larger problem in the industry. Another example could be a bank that reports a certain level of carbon emissions reduction, but upon closer inspection, it's found that they are using accounting loopholes to inflate the numbers. Let's say a bank reports a 20% reduction in carbon emissions. But when we look at their accounting methods, we find that they are including some indirect emissions in a way that doesn't really reflect the actual reduction. This kind of behavior not only deceives the public, but also undermines the efforts of regulatory bodies trying to promote sustainable finance. And it's not just about the numbers. It's about the trust that the public places in the banking sector. If the public doesn't trust the banks to be honest about their environmental impact, it can be very difficult to drive the necessary changes towards a more sustainable future. Then, I'll introduce our proposed architectural solution. I'll break down how the blockchain-based framework is designed, what components it has, and how they interact with each other. I'll also show you some visual representations of the framework to help you better understand its structure. This will include how different nodes in the blockchain network communicate and how data is stored and verified. When we look at the nodes in the blockchain network, they are like the building blocks of a large interconnected system. Each node has a specific role, and they work together to ensure the integrity and security of the data. For example, some nodes are responsible for validating transactions, while others are in charge of storing the data. The communication between these nodes is crucial for the proper functioning of the blockchain. Think of these nodes as a team of workers in a large factory, each with a specific job, and they need to communicate effectively to keep the production line running smoothly. And just like in a factory, if one part of the system breaks down or malfunctions, it can have a ripple effect on the entire operation. After that, I'll share the validation results. These results are crucial because they prove that the transition from the old system to the new blockchain-based system is not just a theoretical possibility. It's a necessary step for the future of sustainable finance in the banking sector. I'll show you how the new framework can address the issues we currently face and bring about real change. I'll go through the data and analysis step by step, explaining how the framework has been tested and what the outcomes mean. The validation process involved a series of rigorous tests, and the results are very promising. They show that the blockchain-based framework can significantly improve the transparency and reliability of sustainable finance in the banking sector. For example, in our tests, we found that the new framework reduced the time it takes to verify environmental data from days to just a few hours. And this time saving is not just a minor convenience. It can have a huge impact on the efficiency of the banking sector and the ability to make informed decisions about sustainable investments. So, let's start by delving into the problem that we aim to solve with our research. Let us begin by identifying the core challenge, the verifiability gap. Currently, the scale of sustainable finance is massive, with ESG-focused assets exceeding $30 trillion under management globally. However, the trust in these assets is fragile. The industry relies heavily on self-reported and aggregated data, creating a significant gap where companies can easily obscure their true environmental impact. This lack of transparency directly enables greenwashing. A critical data point to consider is that ESG ratings for the same company can vary by as much as 60%. This variation is often the result of differences in measurement methodologies rather than actual changes in company performance. To bridge this trust challenge, we must find a way to make environmental data as rigorous and verifiable as financial data. The technical complexity of this task increases when we look at financed emissions, specifically under Scope 3, Category 15. These are not the emissions generated by the bank's own operations, but the emissions produced by the companies the bank chooses to finance. Several methodological problems plague this area. First, current accounting is often based on sector averages rather than real-time data, which PCAF standards label as low quality. Second, we face financial attribution issues where a simple fluctuation in a company's stock price can artificially alter its reported carbon footprint, even if actual emissions remain unchanged. Finally, there is a fundamental privacy conflict. We must find a way for sensitive, private financial data to coexist with public environmental data on a shared system without exposing confidential information to unauthorized parties. Blockchain technology emerges as a compelling potential solution to these challenges. By utilizing key features such as immutability, transparency, cryptographic security, and distributed consensus, we can create a system where data cannot be tampered with once recorded. We have already seen successful blockchain applications in supply chain traceability, green energy certificate management, and the prevention of double counting in carbon markets. However, a significant limitation exists in current academic literature. Most research focuses on carbon credits, which are ex post offsets, essentially cleaning up after the fact. Our research aims to shift this focus toward the accounting of financed emissions, treating them as an ex ante risk that must be managed and verified from the moment a loan is issued or an investment is made. Our primary research question is, how can a blockchain-based framework be designed to ensure verifiable accounting of financed emissions and the automatic enforcement of sustainability-linked financial covenants in the banking sector? To answer this, we addressed 5 specific knowledge gaps. First, the Oracle problem. How do we verify real-world environmental data before it enters the blockchain? Second, privacy. How do we combine private and public data safely? Third, scalability. Can the system handle full portfolios with thousands of counterparties? Fourth, legality. How do we ensure smart contracts align with emerging regulations like SFDR and CSRD? And finally, standardization. How do we link this technological design with established financial standards like PCAF? These 5 pillars form the foundation of our design science approach. For our methodology, we employed design science research, a framework specifically suited for creating artifacts that solve complex organizational problems. Our study was structured into 3 distinct phases. Phase 1 involved requirements gathering, where we conducted a deep analysis of existing literature and legal standards such as the Corporate Sustainability Reporting Directive. Phase 2 was the artifact design, where we developed a layered architecture for a permissioned blockchain system tailored for institutional use. Finally, Phase 3 was the evaluation. We used symbolic modeling through process calculus to provide mathematical rigor, conducted qualitative interviews with 17 experts, including bankers, auditors, and regulators, and performed design-to-outcome mapping to ensure our technical features directly solved the identified business and environmental problems. The result of our research is a proposed 3-layer architecture designed specifically for verification. The first layer is the data source layer, which remains off-chain. It pulls financial data from legacy banking systems and environmental data through a decentralized Oracle network. The second layer is the blockchain layer, acting as middleware. This permissioned ledger uses a consensus-based Oracle network where external data is verified by multiple independent nodes before being committed. This layer also hosts the smart contract environment for automated, verifiable execution of financial covenants. The third layer is the application layer, providing the interface for banks, auditors, and regulators. This allows for the automatic generation of compliance reports that are backed by the underlying cryptographic proof, significantly reducing the manual workload of auditing. Our validation analysis provides strong evidence of the framework's efficacy. Using symbolic modeling, we mathematically prove that the system prevents the double counting of emission reductions and guarantees full auditability, meaning every aggregated report can be traced back to its specific source data points. In our interviews with 17 experts, we found high acceptance for the model, with the permanent audit trail identified as the most significant benefit for the industry. While experts did raise valid concerns regarding the cost of integration with legacy systems and the legal standing of smart contracts, our green loan simulation was a success. We tested the full flow, from tokenization and Oracle verification to emission calculation and the automatic execution of a loan covenant, proving the technical feasibility of the entire process. This research suggests a profound paradigm shift in financial auditing. In the old paradigm, auditing was sample-based, costly, slow, and entirely trust-based. Under our proposed framework, we move toward full system auditing. This gives authorized parties direct, read-only access to an immutable ledger with complete data provenance. For regulators, this opens up the possibility of monitoring the entire financial system's exposure to climate risk in near real time, rather than waiting for annual reports. Furthermore, by solving the Oracle problem through a consensus mechanism among multiple independent data providers, we ensure that the environmental information entering the system is reliable. This creates a foundation of truth that has been missing from the sustainable finance market until now. Despite these advances, we have identified several challenges that will define our future work. Technically, the integration with legacy core banking systems remains a complex and costly hurdle. Legally, there is still significant uncertainty regarding the enforceability of self-executing smart contracts in many jurisdictions. Scalability is also a factor, as we need to ensure the Oracle network can handle high-frequency data for very large portfolios. Our next steps involve developing specific proof-of-concept applications for diverse asset classes beyond simple loans. We are also seeking interdisciplinary collaboration between legal and technology experts to validate contract standards. Finally, we will work toward international standardization of data models and Oracle validation methods to ensure this framework can be adopted across global banking borders. In conclusion, this study presents the first comprehensive, institution-based model that transforms carbon accounting from a retrospective, estimated task into a forward-looking, continuous process. We are advocating for a fundamental conceptual shift, moving from self-reported disclosures to permanently available digital evidence. Verifiability is the new frontier of trust in sustainable finance. Our framework demonstrates that it is technically possible to build a system where every sustainability claim is backed by undeniable cryptographic proof. By adopting these technologies, the banking sector can finally bridge the verifiability gap and play its essential role in a truly sustainable society. Thank you for your attention, and I look forward to your questions regarding how we can implement these solutions to secure our collective environmental future.